All right. Algebra 2, Lecture 120 and 121, OAS A2A17 again. What we're going to do today, the student will evaluate a described geometric series and a geometric series written in sigma notation. Okay, so they're going to describe a geometric series to us. That is, we're going to add up. Remember, the series is the sum of the terms in a sequence. So for the last couple of days we've been doing geometric sequences. We're going to take a geometric sequence and we're going to add up the terms. And in each case, today and tomorrow, the sequences are going to be finite. There will be a first term and a last term, and we'll know or be able to figure out how many terms there are. So we're going to take that described geometric series and evaluate it, add up all the terms, or if it's given to us in sigma notation, we're going to do the same thing. Here's the formula we're going to use. The sum of a finite, that means there's a first term and a last term. Geometric series can be found using this. A sub 1 is the first term. We'll need A sub 1. We'll need R, that's the common ratio, just as we found when we were doing sequences. And N is the number of terms in the sequence. So if we know these three pieces of information, we just plug them in and let our calculator do the walking, and this will add up the terms of our geometric series. Okay? So we may be given a sequence, but if they ask us to find the series, we take the terms of the sequence and add them up using this formula. Okay? So here we go. Looking for the first term, common ratio, and the number of terms. That's all we need for this formula. So let's take a look at what we have here. It says find the sum of the related or described geometric series. Well, in this case it's related because this is a sequence. So I want to find the sum of the related geometric series, which is -4 plus -12 plus -36 plus -108, so forth and so on. And it'll continue this pattern until I get 8 terms. So what I'm going to do is figure out what R is, because remember, what I need is the first term, R, and N. Well, they gave us N right here. That's the number of terms. I'm going to figure out the first term. Well, that's easy enough. -4. Now I got to find R. Well, I find that just by -12 divided by -4 is 3. -36 divided by -12 is 3. So we can easily see that R is, in this case, 3. Now I'm going to use my formula right here. And I'm going to plug in everything I know, first term, common ratio, and the number of terms, and try not to make any mistakes. So here we go. The sum of n terms is equal to the first term times the quantity, 1 minus r to the n, divided by 1 minus r. There's the formula we're going to use. And this formula will add up these 8 terms. I only see 4 of them, but if we continue this pattern until we have 8 of them, this will add them up for us. So I'm looking for the sum of 8 terms, because it asked me for that, is equal to A sub 1, that's the first term in the series. A sub 1 is, what was it, -4? Times the quantity 1 minus R. I found R to be 3. The number of terms is 8. That was given to us. So I'm going to plug that in right here. Divide this by 1 minus R, which is 1 minus 3. Then we perform these operations with our calculator, and hopefully we don't mess it up. And hopefully I plugged in everything correctly. If I didn't, I will be embarrassed. Here we go. I got -13120. -13,120 is what we get if this carries out to 8 terms, and then we add all the terms together. And I'm going to check to see if that's right. Negative 13120, negative 13,120. So yay, we determined, we were given the number of terms, we found the first term and the common ratio. These are the three pieces of information that we need to plug into our formula that will allow us to add up the terms of a finite geometric series. We need to know how many terms there are, the first term, and the common ratio. And we were able to discern that looking at this related sequence. And we were able to find the sum, which we call the series. We'll move this over a little bit here. And that way I'll have a little more room to work here. It says hint, use the explicit form. The reason it says that is because we need n, the number of terms, the first term, and r. And if you look at this is a described geometric series, or sequence rather. It's described to us, and they give us the first term, they give us the nth term, they give us the common ratio, but they don't tell us how many terms there are. So we're going to have to try to figure out how many terms there are, because we need the number of terms. We need that, and they didn't give it to us. So if that happens, if they give you a situation where they don't give you the three pieces of information that you need in a described geometric series, what you're going to do is use the explicit form that we did for the last couple of days in working with sequences, and we're going to solve it for n. We'll know everything up there except n, and I'll show you how to do that. Here we go. I look up here, I say, hey, I don't have the three pieces of information I need. I don't have n. I do have the first term, I do have the common ratio, and I have the nth term, but I don't know what n is, the number of terms. So I'm going to solve that. I'm going to find the n by plugging everything into here and solving for n. So let's see what I have here. A sub n, that's the nth term, is negative 512, is equal to the first term, which they tell us is negative 2, times r, which is, did they give us r? Yes, they did, 2. And we don't know the number of terms, that's n. I'm going to solve this for n. Here's my approach, here's what I'm thinking. I want to get rid of this multiplied negative 2 by dividing both sides by 2. Negative 512 divided by 2 is negative, or positive rather, 256. So I'm dividing this side by negative 2, and that will give me 2 to the n minus 1 when I do that. I'm going to divide this side by negative 2, that will give me 256. Now, I see this is 2 raised to some power. So I'm betting that this is also 2 raised to some power, and I'm going to just count it out on my hands and figure out 2 to what power is equal to 256. So here we go. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256. So this is 2 to the 8th power. 256 is 2 to the 8th power. So I'm going to call it that. And the reason I'm calling it that is because I'm going to use this little piece of logic. If 2 to the n minus 1 is equal to 2 to the 8th, then n minus 1 has to equal 8. 8 must equal n minus 1. If I raise 2 to the 8th power, and it's the exact same thing as raising 2 to the n minus 1 power, then n minus 1 has to equal 8. And if that's the case, now I have an algebra 1 problem, or a pre-algebra problem. Add 1 to both sides, and n is 9. That's the third piece of information that I need. So I found that on my scratch work. And then we'll move this over here. And now I've got the three things I need. I need a sub 1 is negative 2. I've got the common ratio, they gave it to us as 2. And we need the number of terms, which we just found is 9. Now I've got the three pieces of information I need to plug into my formula for the geometric series. So here we go. The sum of n terms is equal to a sub 1 times the quantity 1 minus r to the n. All of this divided by 1 minus r. Okay? And now I'm just going to plug in the information that I just found. I'm looking for the 9th term, so I'm S sub 9. Oops, kind of messy. The 9th term is going to be A sub n, they gave that to us, negative 512, the nth term, times the quantity, 1 minus r, which is 2, to the n, which is 9. All of this divided by 1 minus r, which is 2. So I just hopefully plugged all this in correctly. A sub n, oh, A sub 1, should have been A sub 1, my bad. Thought that was wrong. I'm getting old. You probably caught that while I was doing it. I wrote A sub 1, A sub n instead of A sub 1. A sub 1 is the first term. Okay, so let's take a look at this. Sorry about that. Here's the form for the sum of a geometric series. And for some reason I wrote A sub n because I'm brain damaged old man. Should have been A sub 1, that's the first term in the series. And plugged all that in, making sure I plugged it in correctly, and it looks like it is correct now. So now we just let our calculator do the walking. Don't do what I did. Luckily we caught it early, or I caught it early. So we have negative 2, parentheses, 2 to the 9th, close parentheses. Negative 1022, yay! The sum of these 9 terms will be negative 1022. Yeah, sorry about that. Make sure you use the right formula. Don't do what I did. For some reason, my brain said A sub n, probably because I was looking at this. And I just glanced up there and saw it and wrote A sub n instead of A sub 1, which is the formula. And those are the 3 pieces of information I need. I need the first term, the number of terms, and the common ratio. First term, number of terms, and the common ratio. These are what you have to use our formula. All right, so yay. Let's take a look at another one. Here, this one's described to us. It gives me the first term, the number of terms, and the common ratio. So I don't have to look for anything. I'm just going to say, well, the sum of n terms is A sub 1 times the quantity 1 minus r to the n over 1 minus r. Make sure I copied that correctly because now I'm doubting myself. There we go. Yay! And all I need to do now is just plug in the numbers into the correct places. They gave us everything we know, first term, common ratio, and number of terms. So here we go. I'm looking for a sum of 7 terms is equal to the first term, which is negative 3, times the quantity 1 minus r, they tell us is 5, to the n power, n is 7. All of this divided by 1 minus r. R is 5. Perform these operations, and hopefully don't make any mistakes. It's easy to make mistakes. We try not to. Sometimes we do. And I got negative 58,593, and I'm hoping that's right. Negative 58,593, yay! So that's the sum of this described geometric series. The first term is negative 3, and you would multiply that by 5 and get the next term, then multiply that by 5 and keep multiplying by 5, and that would give us, eventually you'd have 7 terms. This will add up all 7 terms, okay? Okay. The last one, now remember, this is just like when we use sigma notation when we're doing an arithmetic series. The formula that we're going to use to add them together is different, but the concept is the same. If I were to plug in a 1 and then a 2, and then a 3, and then a 4, all the way up to 8, I would have 8 terms. And I can add all of those terms up using this, as long as I can find the first term, the common ratio, and the number of terms. Well, in this case right here, I'll put this in the general form, is the first term times r to the n minus 1. So I'm looking at the first term in the series and the common ratio. And here's the number of terms right here. So here's my first term, common ratio, and the number of terms. And I hope you remember that this sigma notation means we're going to add up this thing after it's been evaluated as n equals 1. That'll give us a number, then n equals 2. That'll give us a number, n equals 3. All the way up to 8, we'll have 8 numbers and add them together. So, here we go. I'll just write down, move this over here. The things that I need the first term, which is what I get if I plug in a 1 here. That's negative 3 times 5 to the 1 minus 1 is 0. Now here's something you need to remember. This will come in real handy on the ACT as well. As long as you have a non-zero number, the number itself is not 0. If you raise that number to the 0 power, it always equals 1. So this is negative 3 times 1, which is negative 3. So my first term, negative 3. The number of terms of my common ratio is 5. The number of terms is 8. And these are the 3 bits of information I need to plug into my formula to add up this geometric series that's described in a sigma notation, or written in sigma notation. Okay, so here we go. I'm going to say that the sum of these 8 terms is equal to the first term times 1 minus r to the n over 1 minus r. And I'm going to plug in my 8 now, or find the 8th term, I'm sorry. The first term is negative 3, and hopefully I haven't made any mistakes. I hate making mistakes. Times 1 minus r is 5 to the n, which is 8, and over 1 minus 5, which is negative 4. Move this down a little bit so it won't be quite so cluttered looking. Okay, I'm going to do that with my calculator, and hopefully I haven't messed up. That's supposed to be an 8, by the way. Make that a little neater so you can read it. Okay. We have negative 3. Minus 5 to the 8th. Close those parentheses, divided, whoops, hit minus negative 3 times 1 minus 5 to the 8th, close the parentheses, and then divided by negative 4. We got negative 292,000. The sum of these 8 terms is negative 292,000. I'll scroll this down just a little bit there. Negative 292,000 968. Hopefully that is right. We'll take a look and see. Find the key. Negative 292,968. Yay! Okie dokie. So there we have it. If it's written in sigma notation, you still just need to find the first term, the number of terms, and the common ratio. So it's a sub 1 times r to the n minus 1. So there's your first term, your r, and the number of terms right there. A sub 1 and r, and n is right here. Okay. Those are the 3 bits of information that you plug in to your formula and let the calculator do the walking. You can do this.